I'm not remotely on shot. Yeah, that'll do. That's not how I sound, alright?
You should have just recorded the audio.
Oh, if it picks up, then he's in the outtakes for that. Yeah.
Hey, interwebs.
Hello, interwebs. Welcome to Let's Fix Computers. I've got a Dell here. This is an Inspiron 5502, and it's not charging its battery. It originally came in as no power, and I was just like, but it would work on the charger. I was like, oh, the battery is knackered. Get a new battery. So I got a new battery, and this one wouldn't charge either. So I put the original battery in, same deal. Now the thing is, the battery is detected. You can see we've got 16% battery in this one. If I put in the third-party one, that will read 15%. Sorry, 50%. But it won't charge it. And on the side of the laptop, our charge light is giving a white and... let's just cover that up. There we go. We've got a white and multiple yellow flash there. So, I don't know, 3 or 4 flashes of yellow followed by white. And that basically means battery fault on a Dell. So, the Windows says it's on charge. So, it's detected the DC input and it says the battery is charging, but no power is actually going into the battery. So, let's get this apart and find out what's going on. So, roll the intro, and I'm going to reorient this, and we're going to explore the Dell charging system. Let's go. Right, so here's our motherboard, and I was kind of hoping that when I took it out and looked on the back we'd get a board number, but I'm not seeing one, so I might have to do some digging to actually figure out what the hell this motherboard is. We've got black plastic covering everything. I'm going to take off the CPU cooler to give myself more access and just really reveal everything, because this one's tough to make anything out. I'm not seeing the circuits that I was expecting to see. So give me a bit moment. Give me a little bit longer. Okay, so here's our motherboard, and the only real hints I've got are these numbers here. This doesn't look like a motherboard number to me, but it's the only writing I can see on this board that really makes any kind of sense. So what I'm going to do is I'm going to do some digging around and find a schematic for this before we get started, because to look at this properly, we need to see a schematic of the charging circuit and how it communicates with the charger. Because the way that Dells work is we've got standard DC input here, and we'll find the usual main power rail and stuff like that. But the other thing we've got going on here is a one-wire circuit, which is where the board's EC, I think it is, will be communicating with the charger down the sense pin to detect what wattage the charger is and whether the charger is okay and stuff like that. And that one-wire sense is probably our issue. There is probably an issue with it detecting the charger, which is why it will run off the charger, but it will not charge the battery because it doesn't know if it's able to or not. So I'm going to go and find a schematic, and I'll be back in just a moment. Right, I said I was coming back with a schematic, but I tricked you. I'm not. I'm coming back with a microscope view instead. So, here's what we've got. I've actually got friends with me today, and they're currently getting hold of a schematic. But in the meantime, I thought I would just start having a look at the connector under the microscope to see what I could see. And straight away, while I was looking at the battery connector, we've got this exposed trace here. Wow, I'll get a smaller pointer than that. Let's try this guy. There you go. You can see this trace coming along here, and that's copper. That's exposed copper. You shouldn't see exposed traces like that. They should always be underneath the blue solder mask of the circuit board. And if we go in really close, that trace is actually blown open. So let's come down for the mega close-up. So as you can see, that trace is actually... Oh my god, this pointer is terrible as well. We've got quality tools in this workshop, everyone. Alright, so as you can see, that trace is actually blown open and there's actually a gap in the trace there. So this is probably why our battery won't charge. The question is what is this trace and what does it do? Well, it's coming from these two vias here. It goes through this bit here. This is all one single pad. It's actually connected across the middle. Goes along there, and it goes into that pin. There's also another bridge, another via there. So we need to figure out the pin out of this battery connector so we know which pin that is. My guess is that this is going to be a system detect pin. We're getting a charge level reading from the battery, which means there's definitely serial communications to the battery. So the clock and data pins, which is going to be one of these three, those are working. However, the other pin is going to be a sense pin that detects if the battery is actually connected or not. And I think that one isn't connected. So ideally what we should do now is figure out the pin out for this battery, and then we can determine what pin that is and just confirm that it's a system detect. And like, we can solder blob out that broken trace and reconnect it, but the question is, why did it blow out in the first place? You know, this is the classic case of when a fuse blows, you kind of want to know why it blew. So first of all, I'm going to go and figure out the pin out for this, and the way I'm going to do that is I'm going to hook the battery up to my battery analyzer, because I can use that to figure out where all of the other pins are, and we can move forward from there. Okay, right, I've just wired in a wiring harness for my NLBA battery analyzer. I need to do another video on this thing at some point because I've got the latest version of it. It's not that much different from the old version, but still this is a really handy tool and it's worth talking about it at some point. But I'll just put that in another video. So at any rate, I'm going to hook it up to this because this allows me to just wire up individual pins of the battery and see how the battery behaves depending on what is and isn't connected. So that's going to give us a bit more information here. So firstly, I'll plug in this wiring harness. And right, so straight away, the output light came on and then went off again. So now I need to figure out the serial lines. So we've got 3 positive connections and we've got 3 negatives with 1 missing. Don't worry about it. And I've got 4 wires remaining, 4 pins remaining. 2 of these are serial connections, so that'll be our clock and data connection. So I want to find those first. And in lieu of having a schematic to hand right now, I'm just going to brute force this. It doesn't actually take that long to do this if you try. So I'm going to hook up. So I'm going to hook up the first wire to clock. And in the software, I'm just going to hit start reading. So it just repeatedly polls the battery. And now I'm just going to touch each of the pins to data one by one and see if we get anything come back. Oh, first try, look at that. All right, cool. So let's hook that up. Right, so now we're getting a read. Let's just stop that for a moment. So how far have we got? We've now got a read of the battery, and I can hit health and capacity. And as you can see, we're communicating with the battery. However, the battery is currently locked. So this is the important bit. We've got serial communications, but the battery is locked, most likely because its system detect pin is not connected. So the battery is going, I don't think I'm connected to any device, so I've shut off the power in out to make sure that I can't be shorted out. So we've got 2 wires left. These are going to be our system detect lines. So I'm going to try, I'll take the first one and I'll just touch that to the ground pin. And let's just pull that all again. Read once. Still locked. Okay, let's try the other one. And when I touched this one to the ground, the output light came on. So read all once again. Now the battery is unlocked. So now the system detect pin is grounded, it is pulled low. The battery is now saying, I'm plugged into a laptop. I will now send and receive power. So we've now figured out the pin out for this battery. So what I'm going to do now is we're going to go back to the motherboard and I'll just overlay that pin out and we can see if that lines up with our blown power trace. Right, so we've determined that this pin here is our system detects line, and I have actually acquired a schematic for this, and when we look at the schematic, that is on the motherboard, this is labeled as a ground pin. And what's going on here is Dells have a bidirectional protection on the batteries. So on the battery, this is a sysdetect pin, and the battery pulls this up to 3.3 volts or 1 volts or something like that. We're going to have a look in a minute. And then the laptop pulls this to ground through here. This is a ground pin. And so when this pulls that line to ground, the battery knows it's connected to something. Then the next pin over is sysdetect on the battery side. So the motherboard will apply a small voltage to this pin, and the battery will pull that to ground, so the motherboard knows that it is connected to something. So that one is probably okay, but we're going to buzz them out in a sec to check. So the fault we've got here is that sysdetect on the motherboard side here has blown open, and there's no real sign or reason for that to have happened. So it's a bit, So what I'm going to do is I'm going to just do some measurements on the two batteries I've got and see what we can determine there. So let's grab a battery. Here's a schematic view of the battery connector with a battery drawn in. So at the top we have the positive connection from the battery, and that goes along up to the BT plus rail, so battery terminal plus, and that provides power into the laptop. At the bottom we have the negative connections going down to ground. In the middle, these yellow and green wires represent our serial clock and serial data lines. These are intact, which is why the laptop can communicate with the battery and measure its charge status. Next, we have this blue line, which is PBAT present. This is the system looking for a battery. So it's pulled up through R4310, and inside the battery, that pin is shorted to ground. So when the battery is connected, that line is pulled low and the system knows that there is a battery connected. Then finally, we've got the purple one, which is system present. This is the battery looking for a laptop. So inside the battery, this line is pulled up and the BMS is watching that line to see if something pulls it down. When the battery is connected to the laptop internally shorts that down to ground. So then the battery knows that it is connected to a laptop and thus switches on power. This is the line that is broken. So as far as the system is concerned, everything is okay, which is why Windows says that it is charging the battery, because the laptop is satisfied that a battery is connected through PBAT present. However, the battery is not satisfied that it's connected because system present is broken. So the battery is connected, but it refuses to accept or deliver any kind of charge. Right, so we're back on the motherboard now, and I've got the battery connected. So let's do some more measurements. So firstly, I'm just going to go from ground to B+ and see if there's anything there. And there's nothing there. So this is why the battery is not charging or powering the laptop, because the battery is not switching on. And let's just check out that system detect pin. There we go. See, now we're seeing 2.4 volts there. That's 2.5. We'll round that up. So there's 2.5 volts there. So presumably the battery needs to have some connection for it to actually look for that sysdetect. So let's move up to the next pin. And there's nothing going on there. But I would wager if we put DC power on the motherboard, we would see something there. Okay. So what I'm going to do now is I'm going to disconnect the battery and I'm going to connect the DC jack, and we should see that the other pin, so the motherboard to battery sysdetect pin, that goes high. And then that will just illustrate how this battery protection actually works. And what we want to do is we want to see if there's some kind of leakage somewhere, like something is just leaking current into that trace that exploded it for some reason or other. And I'm not really sure what I'm looking for here, so bear with me, but let's just prove these sysdetect pins first. So I've got a DC jack plugged in now, so now we're going to go over here, and so let's check that same pin. This one's going to be 0 because there's no battery connected, and it is. So now let's check the next one. And now as you can see, we've got 3 volts on this pin. So the motherboard is trying to feed 3 volts into the battery to see if there's a battery there. And inside the battery, this pin will be pulled to ground to signal to the motherboard that yes, I am connected. So that's the bidirectional system present line here. And we've seen similar stuff to this on Apple laptops that also have a sys present pin. But those only have a single one from the battery to the motherboard, not the other way around. I'm not quite sure why Dell has one going the other way around. Like, I can't see a world where you need to be careful of shorting this out because it's inside the laptop. It's understandable that you'd want the battery to not be hot in case it's not connected to something, but whatever. Anyway, so those are our system present pins. Right, so what we're going to do, I've switched multimeters because there's a fuse blown in my VC99. Don't worry about it. So what I want to do now is we want to see how much current that sysdetect pin tries to pass. So it's plugged into the laptop, and I'm going to put my black probe... no, actually I need to put my red probe on ground because I'm measuring current. We're doing this in series. And so now, when I press this probe to this pin, it's going to pull this line to ground through the multimeter, and the multimeter should show how much current is being passed. So let's see what happens. Nothing. Nothing. Right, so we got a reading of 0, so I'm going to swap the batteries over because that doesn't seem right. Unless I need to be reading like microamps on this. It is going to be like a really small current because it's just a signal. You know, this isn't like a load or anything like that. So I'm just going to get the other battery connected and we'll see if we get anything from there instead. It's quite possible that we'll just never know. Maybe a bit of wire was in the computer. Maybe a staple fell into the computer and shorted out the battery. You know, it would just be awesome if we can get some kind of reading on this that just demonstrates a failure mode. Let's try again. So, once again, we're going to short this to ground through the multimeter. That looks like nothing to me. I'm going to try the microamp range. I can't see a world. I don't know if this is going to work, but I'll try it. We should be getting something though. There we go. Or maybe. Okay, well we got a response there, so let's switch back to the other battery again and see what it does. Although, I don't know, man. We're measuring so small here, and I don't have the correct equipment for measuring currents this small. So these might be nonsense readings. I'm just looking for something different between the two batteries. What I want to see is that the old battery is leaking an excessive amount of current, and then we can just blame it on the old battery and say that was passing too much current through the sysdetect, and then we can just say, cool, the old battery was faulty. That's the answer. Same test, different battery. Here we go. Oh, look at that. That's way higher. Now, again, we're in microamps here. So that's 2.4 microamps, but that's actually showing a reading on the scale. The other battery, we were looking for like 0.1 microamp or something like that, whereas this is actually showing 2.4 microamps. There's actually a current reading there. Whereas so we have got a difference between the two batteries. So, like, we're getting an incredibly small current reading, and I think that current reading isn't very accurate because I'm not measuring this properly. For measuring microamps, you need specialist setups to avoid burden voltage and complicated multimeter stuff that I don't understand. But we saw a difference. That's the important thing. And one more reading I'm going to quickly take is I'm just going to do this while the DC jack is plugged in, because it's going to try and charge the battery now. And if we see that current go way up, then the battery is just leaking through it. Here we go. No, same reading. So, again, I don't trust that reading of 2.4 microamps. I don't know if it's actually higher or lower than that, because I don't really know how to probe this properly. But once again, it was different to the other battery. That's the bit of information that I'm clinging on to here. So, one more test. Let's plug in the new battery and see how that behaves when it's on charge as well. Ah, look at that. Yo, that's way different. 35 microamps on the new battery. Okay, so I don't know what these numbers mean. All I know is that I'm getting wildly different results. So it's possible that the old battery is internally damaged and is just not actually showing what it's doing. At some point, it just put passed power through that or leaked power through that. But I'd have to start taking the other battery apart. You know what? We're going to get this laptop, we're going to fix this line, reassemble the laptop, and then we'll take one more look at the old battery. I'll open that up if I can, and we'll have a look at how that wire is actually connected internally in the battery. Okay, right, I have reassembled the laptop, and as you can see at the top of the screen here, the laptop is on and working. The battery is currently disconnected, so now what we're going to do is we're going to connect the battery and see what happens. Right, so I'll disconnect the power now, so the laptop is now off, and let's connect the battery. Alright, nothing has caught fire. As a quick test, I'm just going to check if there's any heat forming around that join. No problems there at all. No heat. Cool, let's plug in the charger. And we've got a white light. And a white light, that's charging. So the laptop now says it's charging the battery, so that's more than we had before. We're not getting the warning light anymore. So now if we fire up the laptop, well, I mean, we'll still see that there is a percentage reading, because there was last time, but we should see that the percentage is actually going up now. Right, and the battery is already at 51%, so we've already gone up by 1%, so that's a good sign. And it's also saying time until charged, so that also infers that we're actually charging for realsies now. So what I'm going to do now, 52%. All right, well, that's it. We've solved it, everyone. So at this point, I'm blaming it on the old battery. Now, I did start peeling up edges, and I peeled off the back of the battery and stuff to see if I could get to the BMS, and I was kind of hoping that I'd be able to try and have a look for the pull-up resistor for the sys-detect pin and stuff. But the BMS is buried under this plastic. I'd have to cut this battery apart to get to it, and even then, there's no guarantee that we're going to find anything. So I'm going to assume that there was a freak accident with this battery. There's also a non-zero chance that, as I mentioned earlier on, something could have fallen in the laptop. You know, a pin, a paperclip, a staple, who knows. So I'm going to send it, see how we get on, and we'll just monitor it. You know, this is why you warranty your jobs, basically. So that's it, everyone. That's the end of the video. So thank you, everyone, for watching. And now today, I do want to give a very special thank you to my production team. So production team, if you'd like to just show yourselves for a moment. The videos wouldn't be possible without them. They're very expensive, so please subscribe to the Patreon. The links are in the description down below. Thank you, everyone.
Cheers.
Goodbye.